On page 17, it says a student has a collection of baseball cards that they've collected over several years. Suppose that capital B, the number of cards in the collection, can be described as a function of t. It's a function, okay, which is time in years since the collection was started. Explain what each of the following equations would tell us about the number of cards in the collection over time. I really like this problem, okay? So, again, we have a collector of baseball cards, capital B, the number of cards in the collection, and it is a function of time. Okay, explain what each of the following equations would tell us about the number of cards in the collection over time. So I am going to give you and a partner. I want you to get with a partner, unless you really, really, really want to work by yourself. 5 minutes to come up with a generalization of what is going on in each of these equations. Okay? Janetta, do you want to work with a partner? Sure. Andrew, do you want to work with a partner? No? Nyla, would you want to work with a partner? Okay. How about Janetta and Nyla? Are you two wanting to work? Work alone? Okay. Schneider, you want to work with a partner? No? Sean, do you want to work with a partner? It's up to you. No? Okay. Nehemiah, do you want to work with a partner? Okay. Christian, do you want to work with a partner? No? LaShawn, do you want to work with a partner? You don't care? Well, I would say you could work with the girls or you could work on your own. That's up to you. What about you two? Jaden and Kaylee? Are you guys okay working together? Okay. All right. Most people are working alone, just a couple. So, LaShawn, I'll leave it up to you. You want to work with them, kind of? Just say yes. Just say yes. The more the merrier. All right, I'll give you 5 minutes. 5 minutes. Come on. Here, let's take these out. Take them out. It's okay, it'll be all right. Good. I like it. I like it. Maybe you can overhear what they're saying, you know? That might be good. So capital B is the number of cards they have in the collection over time. What is going on with the cards in the collection? Remember, these are functions, so they are linear. So maybe the cards are increasing, maybe they're decreasing. Okay? Devinus, let's put that away. Focus on this. Grab a calculator if you want. What? Oh, we're on page 17.
Oh, I was supposed to say 19.
Nope, page 17.
Are you taking a test?
No?
Okay, I talked to Snyder real quick, please.
Yeah. Schneider? So you're writing kind of like a sentence, what is going on in each of the equations. Y equals mx plus b. It might not be in that order. Oh, Jemiah. Andrew Christian, LaShawn, Janetta. No, Kimani. No, Kimani. So what's going on in that first one? B equals 200 plus 100t. If t is a year. I think it said a year.
Yeah, it's the time in years. But what's the 200 mean?
Well, when you think of y equals mx plus b, the 200 would represent what in the equation y equals mx plus b?
The 200 is the B.
Right, which is the
Y-intercept.
uh-huh. Sean, how are we doing? What are you thinking?
It's the number of cars.
Total
T
number,
is the time.
right?
So I get, I don't know what the numbers are though. But when it's 200, then it's really simple.
Okay, so these are linear equations. This is similar to y equals mx plus b. So, and when I say y equals mx plus b, the 200 would be what part of y equals mx plus b?
M. Or no, this would be M.
Yes,
so
good. It's the
Y.
b, the y-intercept.
Okay.
So if that's the y-intercept, what does that mean? It's on the y-axis.
It's what increases, it can go up or down.
Okay, if it increases, it would go up. This is your slope, right? So that is increasing
Over time.
over time, yes. But what might that 200 be? Please keep that away. All right, so let's talk about these. We have baseball cards. A student has had these cards over several years, right? Suppose that capital B, the number of cards in the collection, can be described as a function of t, which is time in years since the collection was started. Explain what each of the following equations would tell us about the number of cards in the collection over time. Okay, so these are all similar to y equals mx plus b. Okay, y equals mx plus b. So letter A says capital B, the amount of cards they have in the collection, is 200 plus 100t. Schneider, please put that away. So what does that represent? What's going on in that equation? Who thinks they might know? Raise your hand just so I can kind of see who has a handle on this, maybe who doesn't. Okay. Kaylee and Jaden like, maybe. Andrew, do you have any idea on letter A? Andrew, do you have any idea of what's going on in letter A? Oh, did everybody hear what he said? Okay, can you say it louder and slower?
He gets 200 baseball cards. No, he starts with 200 baseball cards and gets 100 every year.
What do you guys think about that? Because that 200 is your y-intercept, right? This is your b, this is your m, your slope, and that is increasing. So he starts with 200 baseball cards, baseball cards. And every year he acquires, gets, whatever you want to put, 100 more to add to his collection. Now, you don't have to write all of that, but that is what is happening. To add to the collection. Is that what you guys were thinking? Janetta's group, Nyla's group, LaShawn's group? Good. Does that make sense to the rest of you now? So the y-intercept is how much you start with, and your slope is telling you, are we increasing that amount in a year or are we decreasing? And it would be the same amount every year, right? So letter B says capital B is equal to 100 plus 200t. Who can tell me what that would mean? Nyla. So he starts with 100 baseball cards, and each year he adds 200 cards to the collection. Only 200 cards, okay? Because it is a line. It is going to be the exact same every year. All right. How about letter C? Okay, so doesn't tell us his name, does it? The student begins with 2,000 cards, and he, what do you want to say? Loses, donates, gives away, because he's methodically, or sells off maybe. He sells 100 cards every year. It's got to be something that they do consistently year after year. He sells 100 cards every year. Maybe he takes his 100 worst cards that he doesn't like. All right. And letter D. This is the most interesting one. Letter D. Sean, what do you think's going on here? Based on what we've said. Uh-huh. And say a little louder, but that what?
Doesn't seem right.
Yeah. Because if you only have 100, how can you give away 200 every year, right? So it starts with the student has or begins with 100 baseball cards, and let's say sells 200 cards every year. But, and this is a big but, that does not make sense in real life. In real life. That is the key. Would it be okay mathematically? Yes. Mathematically, you can draw a line and it can go into the negative amounts. But if you're talking about real life in the positive quadrant 1, it does not make sense. You can't have 100 cards and then try to give away 200. Well, you can, but you're going to get in a lot of trouble. Any questions about page 17? I love that page. Get you thinking. All right, let's turn to the next page then. Is everybody done writing? Should have asked. Everybody got this down? Okay, here we go. It says, which of the following could be modeled by... I'm sorry? Okay. Which of the following could be modeled by the equation y equals 2x plus 5? Y equals 2x plus 5. Okay? Answer yes or no for each one. So, letter A, B, and C. Let's see. And then there's some more. So, we'll do 3. I'll give you 3 minutes for each one. If you want to go back to partners, I'm fine with that. If you want to try them on your own, I'm fine with that too. Which of the following could be modeled by 2x plus 5 is equal to y? Answer yes. Answer no. Let's see what we get. I need my cheat sheet on this one. This one's can be challenging for a few. Gotta watch my time. Oh, we got lots of time. Only A, B, and C, but if you get done and you want to go D, E, and F or head that way, we'll be doing those next. Devinus, put that way. You really need to focus on this, okay? All right. Okay, here we go. Which can be modeled by y equals 2x plus 5? There are initially 5 rabbits on a farm. Each month thereafter, the number of rabbits is 2 times the number in the month before. How many rabbits are there after X months? So is this a yes? We can model it with y equals 2x plus 5 or a no? How many say yes? Okay. How many say no? Got a lot more yeses. So how I did this is setting this up, okay? Initially 5 rabbits, so that would be your y-intercept, right? For month 0, that would be 5 rabbits. Now, it says each month thereafter, the number of rabbits is 2 times the number than the month before. So in the month 1, how many rabbits would I have total? How many rabbits would I have total? Well, if we started with 5 and they're doubling, how many rabbits should I have? Each month thereafter, the number of rabbits is 2 times the number in the month before. So if I take times 2, this should be 10. And this should be 10 times 2 would give 20, right? And 20 times 2 would be 40. 40 times 2 would be 80. Whoops. 80 times 2 would be 160. So let's see, does this seem to work with this equation? If I take, these are my x values right here, the number of months, that's your independent. They just keep going, right? And then the rabbits, they just keep going, they double. So 2 times 0 plus 5, that does give me 5. So this one does work out. But once I get to month number 2, 2 times 1 is 2 plus 5 is 7. So that does not seem to work out. 2 times 2 is 4 plus 5 is 9. That doesn't work out. That one doesn't work out. Neither does this one. So the correct answer there is no. No. All right. Letter B. I don't even know how you say that. Joaquin? Joaquin? Joaquin earns $2 for every magazine sale. Every time he sells a magazine, he also gets a $5 tip. How much money will he earn after selling X number of magazines? So X is equal to the number of magazines that he sells. Okay. Is this a y equals 2x plus 5? Does that go along with that? I see some of this. I see some of this. Well, let's think about it. If we substitute in 1, so if he sells 1 magazine, 1 subscription, he gets $2 for that, right? And he gets a $5 tip, right? What if he sells 2 magazines? Substitute 2 in for X. He gets $4 and he's supposed to get a $5 tip. But you've got $4 plus 5. Isn't he supposed to get a $5 tip every time he sells? Yeah. But that's just one $5 tip for all that he sells. So is this a good representation of 2x plus 5? No, it is not. What would be a good representation of what they're talking about? Y equals 2x plus, what would that be? 5x, yeah. So basically, he's getting $7 every time, because you could combine those and say y equals $7 for every magazine that he sells, because he gets the $5 tip plus the $2 for the subscription. Okay? Now, does it ask for that? No, that's just a little extra. Letter C, Sandy charges $2 an hour for babysitting. Parents are charged $5 if they arrive home later than scheduled. Assuming the parents arrived late, how much money will she earn for X number of hours? Does this equation work for that situation? I see 2 yeses. Anybody say no? That is correct. That is our first yes. Any questions on those 3? All right, let's go to the next one. How much time do I have? 54. I think we'll do these together. I have a sequence of integers. The first term of the sequence is 7, and the difference between any consecutive terms is always equal to 2. The first term of the sequence is 7, and the difference between any consecutive terms is always equal to 2. So this would be the first. This would be the second term. This is the terms. And these would be the integers. So, first term is 7. The difference between any consecutive terms is always equal to 2. So the second term should be what? According to what it says. 9? The difference is always 2? Maybe. So the third term would be 11. Fourth term might be 13. Now, does this work for y equals 2x plus 5? If I substitute 1 in for x, y equals 2x plus 5, then yes, this one works. If I substitute the second term in, 2 times 2 is 4 plus 5 is 9. That seems to work. 2 times 3 is 6 plus 5 is 11. That seems to work. 2 times 4 is 8 plus 5 is 13. That seems to work. So does that represent what's going on in this problem? Yeah. Why didn't we subtract? It does say it's a difference of 2, right? Oh, my cheat sheet's up here already. So let's subtract. Let's go the other way. Let's check it out that way. So, the difference between any consecutive. So you're saying 2 could be 5. Oh, wrong way. She's saying, what if we subtracted? Because the difference between 7 and 5 is also 2. So if I go, in this case, 2 times 2 is 4 plus 5 is 9. That would give 5. And the next one, the difference between 2, what if I said this was 3? 2 times 3 is 6 plus 5 is 11, but this is 3. So this one, first term, and the difference between is always equal to 2. I think we're going to have to say no. What we can say is if you increase the numbers by 2, it would work. But if you are decreasing the numbers, it does not work. Would you agree with that? Yeah. So if you increase the numbers by 2, if you go up by 2, it would work. But if you decrease, it will not. It will not. All right, next one. Sneak Preview is a members-only video rental store. There is a $2 initiation fee and a $5 per video rental fee. How much would John owe on his first visit if he becomes a member and rents X number of videos? Is that the same? Is that y equals 2x plus 5? No, what is that equation? Yeah, 5x plus 2 is what works here. Okay, so it is not this. So this is going to be a no. Andy is saving money for a new CD player. He begins saving with a $5 gift and will continue to save $2 each week. How much money will he have saved at the end of X number of weeks? Is that y equals 2x plus 5? Yes, that is the epitome of it. You start with 5 and you continue to save as long as you are saving. So that is a yes. Okay. All right. Page 19. Is it 19 on yours, or is it at the bottom? A checking account is set up with an initial balance of $4,800. $400 is removed from the account each month for rent. No other transactions are occurring. Write an equation whose solution is the number of months M it takes for the account balance to reach $2,000. A checking account is set up with an initial balance of $4,800. $400 is removed from the account each month for rent. Write an equation whose solution is the number of months M it takes for the account balance to reach $2,000. So this is similar to one that we've had before. Does anybody want to give me an equation? Write an equation whose solution is the number of months M it takes for the account balance to reach $2,000. Say it again a little louder. 2,000. Write an equation whose solution is the number of months M it takes for the account balance to reach 2,000. That is equal to 4,800 minus 400 M. So, write an equation whose solution is the number of months M. So we would need to solve for M here. It takes for the account balance to reach 2,000. What do you guys think of that? Is that good? Yes? No? Maybe? Yes. Make a plot of the balance after M months for M equals 1, 3, 5, 7, 9, 11, and indicate on the plot the solution to your equation in part A. Okay. Before we start to do that, let me show you. So, I think I said homework number 2 was due tonight by midnight, so I will be looking at that. Homework number 3. It's like we have no homework, and all of a sudden, here it is. Homework number 3, writing equations in the context. It is page 20 in your book. Make sure you put the answers on Canvas, okay? So let's go back to this one. Make a plot. A plot. We're talking about a graph. Okay. So here's my graph. What's going to be my independent variable? What goes on no matter what? The months. Yeah, the months are going to go. So this is number of months on the bottom. And what's my dependent variable? What would we call that? Money left in the account, maybe? Money in account. All right. And what's the highest I need to go? What do I need to make sure I cover here? Yeah, I at least need 4,800 because that's where we start. Okay, I'm going to put that way up at the top here. Maybe extend that a little bit. So here's 4,800. And if I divide that in fours first, let's see, that would be $1,200. And that would be 2,400. And this would be 3,600. And in between each of those, because we are removing $400, so it takes three $400 to make up 1,200. Does that make sense? So this would be 400, this would be 800, 1,200, and then 400 more. 16, 2,000, 2,800. Okay, you can keep writing those. Months, it said we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, who loves to make graphs on their own? Nobody. But it is good practice. And when you are doing these on Canvas, we do want you to do them on paper. Okay? Do not use Desmos or anything like that. We know Desmos can do it once you give it the information. We want to see if you can draw the graph. Okay? So, let's see here. Apply the balance after M months. So, after 0 months, I would have exactly 4,800. After 1 month, I would have this month, much. After 2 months, I would have this. After 3, whoops, that's a little big. After 4, 5, 6, 7, 8, 9, 10, 11, 11. And then if I would get to 12, that would be my x-intercept. And there you go. That is for the equation 2,000 equals 4,800 minus 400 m, where m is your number of months. Okay? So again, homework number 3 is now on the docket. Please use page 20 to help you. All right. Good work today. What? I don't know right offhand. I can look. Tell you tomorrow.
Tomorrow.
Yeah.
So I could write it on my calendar.
Your calendar?
Yeah.
Yep. Good for you. Very nice work today. Yes. I don't think anything's really thrown you at all yet.
No, not yet.
Yeah.
We're gonna see.
Yeah.
Keep it at yet.
Yeah, that's right. That's right.